Hello everyone, this is a video on searching techniques. What is searching? Searching is finding a particular item in a collection of items. There are several advantages to searching. They are efficiency, accuracy, scalability, automation, and optimization. Now let us look into the types of searching techniques. There are two major types of searching techniques. They are linear search and binary search. First, let us see about linear search. It is a searching algorithm where we search for an element in a given array by traversing through the entire array from the start till we find the desired element. Now let us see the flowchart for linear search. First, we check if there are elements in the array. If there are no elements, then we declare element not found. If there are elements present in the array, then we start searching from the first position. We compare the element at that position with the desired element. If they are found to be equal, then we declare element found. If else, we move on to the next position and start comparing again. This continues until an element is found or the end of the array is reached. Now let us see an example for linear search. Consider a heap of books with each book containing a unique number on it. And these numbers are not in any sorted order. That is, they are not in ascending order or descending order. So, if we have 5 books and they are numbered as 1, 4, 7, 3 and 5, as you can see, they are not in any sorted order. And if we have to find one book, for example, book numbered 7 in the heap containing the books 1, 4, 7, 3 and 5, we start from the first position, that is the book containing number 1, and we see that 1 is not equal to 7. Then we move on to the next position, that is the book containing number 4. We see that 4 is not equal to 7. So now we move on to the next book containing the number 7 and we see that 7 is equal to 7. So we found the desired book containing the desired number. There are several difficulties in using linear search. They are like the time complexity could be or in the order of n at worst cases, and there are issues of memory usage, and this linear search is insufficient for large data set, and it is also not suitable for sorted list, and it also has only a limited search capabilities. Now let us see what is binary search. Binary search is a searching algorithm which is used only in sorted arrays where we repeatedly divide the array or search interval in halves until we find the desired element. Now let us see the flowchart for binary search. First, we start by reading the array A and the value, the desired element as x. Then we set n to the length of A and we set the pointer variables beginning beg as 0, end as n minus 1 and the result which contains the position of the desired element as minus 1. And we see if beg is less than or equal to n. If it is not, then we stop, which means the array is empty. If beg is less than or equal to n, then we compute the position of mid, which is computed as beg mid is equal to beg plus n divided by 2. And we compare the middle element with the desired element. And if we find that the middle element is less than or equal to the desired element, then we update the pointer value beg as mid plus 1 and result as mid. If the middle element is greater than the required element, then we set end pointer as mid minus 1. Now let us see an example for binary search. So now let us consider books in library where books are ordered as you know, and we consider each book contains a unique number and these books are ordered or sorted according to these unique numbers. Consider a case of 5 books containing the following numbers that are 1, 3, 4, 5 and 7, where we search for a book with the number 3 in the library containing the following books with numbers 1, 3, 4, 5 and 7. The blue numbers, that is 0, 1, 2, 3 and 4, indicate the position of each book, which is similar to position of elements in array. Initially, beg is set to 0, end is set to 4, and we compute mid as beg plus n divided by 2, which is 0 plus 4 divided by 2, which gives us 2. Now comparing the middle element to the element to be found, that is middle element which represents a of 2 gives us 4 and the element to be found is 3. We find that 4 is not equal to 3 and 4 is greater than 3. So we set end is equal to 2 minus 1, which gives us 1. Now we see that beg is set to 0, end is 1, and we compute mid as 0 plus 1, that is beg plus end divided by 2, which gives us 0, considering only the absolute value. Now, since the middle element points to the element at position 0, a of 0 gives us 1, and comparing 1 and 3, we find that 1 is not equal to 3 and 1 is also less than 3. So we update beg as beg is equal to 0 plus 1, which gives us 1. Now beg is equal to 0, end is set as 1, and mid, which is beg plus n divided by 2, gives us 1 plus 1 divided by 2, which is 1. Now, comparing the middle element with the desired element, we find that a middle element is the element at position 1, which is 3, and the desired element is also 3. So, since 3 is equal to 3, we have found the desired element. There are also some difficulties in binary search. Binary search requires a sorted list, and it also uses additional memory for pointers like beg, end, and mid, and the time complexity for insertion and deletion has to be considered, and in the worst case performance, the complexity tends to be in order of log n, and there are also limited search capabilities offered by binary search. Yeah, we are at the end of the video. Thanks for watching. Now scan this code and take up the quiz. Thank you.